Hello, my name is Steven. Welcome to Hyfindr Tech Talks, where we understand the technology that makes the hydrogen economy work. Today, I will be talking about hydrogen fittings. I think they are omnipresent in hydrogen applications, so they are well worth a look, and I am particularly pleased that today I have a distinguished gentleman joining us from Spain, from the company called Redfluid. He's general manager and director of that company. He himself is an engineer, marine engineer. He's worked in all kinds of fluids. Redfluid does this for many other areas as well. And I think he's even working on a Ph.D. in that topic. Enric, Enric Palau, it is a great pleasure to welcome you to this Hyfindr Tech Talk. And I see
hello.
I see you are connected to us directly from your lab. Are you working on your PhD there, or where are you?
Yes, exactly. I'm right now in the hydrogen laboratory of Redfluid. And yes, a small minute I always have some test going on. So I need to check how the test is going for the PhD.
Yes.
But hopefully I will finish very soon.
Okay. Yeah, just to clarify that you have been running Redfluid as a general manager for many years. So it's not that you are, but this is just something that you're doing. Because I wonder when you do that. But I guess that is another topic. Let's talk today.
Yes, I started the PhD just as a hobby, but also to improve a little bit the knowledge about hydrogen valves and fittings.
Yeah, okay, so perfect. This fits then perfectly into this. And today we want to talk about hydrogen fittings. So please, Enric, can you kick us off by telling us what is a hydrogen fitting?
Okay, so here I have two tubes, okay? And imagine that inside the tube is flowing hydrogen.
Yeah.
So how do we connect this tube so it makes a sealed connection? So we use fittings to connect tubes or pipes. So this is one of the key problems also in the hydrogen terminology.
Okay, so to correct tubes and pipes. So, okay, just to enter there, what is the difference between the tube and pipe? Or what was one of them, a tube and a pipe? Can you help us there?
Yes. For example, here I have a tube, half an inch.
Yes.
And here I have a pipe, half an inch.
Yes.
And you can see that the diameter is very different one from the other.
Even though they are both half an inch.
Exactly. So that is so confusing that it's something that needs to be clarified at the very, very beginning of the project.
Yes.
If you are going with instrumentation tubing, with piping, or maybe they are both and you use connections to interchange and connect both of them.
Yeah.
So that's the first step. And then according what pipe or tube you have specified, you will need to use one type of fitting or another.
But is there a physical difference between a tube and a pipe? Can I see the difference?
Yes. So a tube a tube usually it's used for instrumentation. So it's more famous for small diameters, and we call usually with we speak generally with outside diameter, OD. Yes. Outside diameter. Yes. So for example, half an inch corresponds to 12.7 millimeters OD.
Yes.
Regardless, half an inch of a pipe, this is called a DN, and then it's an ASME standard, is ASME B36.10.
Yes.
And then we call DN half an inch, so it corresponds to the outside diameter of 21 millimeters.
Okay.
So that is the main difference. So, and then the wall thickness, the wall thickness, instead of saying, okay, wall thickness is, 2 millimeters, we called a schedule. So we need to go inside the tables of the standard and check schedule 10, schedule 80, schedule 160. Depending on the schedule, it will mean more or less wall thickness.
Okay, perfect. So now that means that the pipes, they can also be really big. Is that correct? Like the one that connects two cities, it can be
exactly. Okay, that's it. Some pipes you maybe can walk inside the pipe. So imagine how big they can be.
Okay, cool, perfect. Well, thanks for clarifying us on that. And I know we want to talk about fittings. So let's get quickly to this. And can you tell us a little bit about the different types of fittings that there are?
Yes. In the world, there are a lot of fittings.
Yes.
And then many manufacturers have their own type of fitting that it cannot be mixed with other companies.
Yes.
But we are not talking about these patented fittings. We are talking about the standard fittings that are universal for the hydrogen economy.
Yes.
So, for example, very famous fitting, a threaded connection.
Yes.
So it means that it has a thread, and it can be connected a male to a female.
Yes, yes,
yes. Usually the most famous thread using in hydrogen is NPT standard. So is this one that say NPT, or maybe in Europe you can find a lot of BSP, but the most famous is NPT.
Okay, so we have a table here to see that exactly. So that was the threaded one. Okay.
Yes. So then we have welded connections. So welded connections, it means to when we are going for a welded solution for the installation.
Yeah.
So it's not a mechanical assembly like the other ones that it's free of welding. You will need to weld that. Then when we go inside, we'll see what different kinds of weldings we have.
Okay.
Then we have what we call twin ferrule fittings. That it's something like this. We'll go later on.
Yes.
But the word it says already. It has two ferrules, two small rings inside the fitting.
Oh, okay.
We'll see why they are used. Same one or very similar, but it's called single ferrule fitting. So inside the fitting, we have only one ferrule or one ring, only one. That's why it's single ferrule.
Yeah.
Then we have cone and thread solutions. This one is the better for instrumentation and for very, very high pressures. When we are talking around 1,000 bar or more, we need to go to cone and thread solutions.
Okay.
We'll see that later on.
Yeah.
And then, of course, we have flanged connections for low pressure.
Yeah. Okay.
So
that's just press
that's
on.
a flange.
Okay.
Exactly.
Okay. So, Enric, I know you have them all there, and maybe just for us to get more clarity on them, can you just take us a little bit deeper? And I know we're gonna run a little bit for time, but can you just take a little bit deeper of each of these type of fittings? And I know you make them, you test them, and you can also tell us like what, how this works for hydrogen and what kind of pressure it will take, for example.
Sure. I will explain just a little bit advantages and disadvantages of each one.
Yeah.
For example, NPT and BSP. Yeah. So that is very famous. It's so easy. It's easy to install. It can handle up to maybe 600 bar. Even I will not recommend for these higher pressures for hydrogen, because if you are going to leakage rates, even you use a lot of sealing material, etc. There's always a little bit of leakage.
Yes.
So for hydrogen, it's not maybe the best solution. But for low pressures and installations, maybe sometimes I have seen it a lot. It's not a major issue, but it's not maybe the best fit.
Yes.
Let's go to the next one. Welded solutions. That one, even some people get surprised, is the most famous at the end, because a weld solution, it's been working for many, many years. Everyone knows how to weld. It's not difficult. Well, it's not as difficult as something else to weld, and it's well known. Also, the tests when it's the connection it's welded, are very known by everyone. So even you can do X-ray, liquid penetrant test, etc. Yeah. So we have two types of fittings to weld. This is a socket weld fitting. That when we say socket weld, it means that the pipe goes inside the fitting.
Yes, yes.
So, and then you will weld around here.
Okay, understood.
On the other hand, a butt weld fitting, like this one, the pipe will connect just in front of the fitting, like that.
Okay, and then it will be welded.
It will be welded here, around the T, exactly. Around here.
Okay.
For hydrogen, the most famous is butt weld fitting. If you are going for fitting for welded connections. Why? Because it's much cleaner. You are not creating something inside that it will be almost impossible then to clean. For hydrogen, it's very important to maintain the purity of the hydrogen across all the pipeline. So when we are welding, we are creating a little bit of small debris, a little bit of something that is not particularly very clean.
Yeah.
So we need to flush it a lot. So it takes a lot of time and a lot of flushing of water to clean a welded pipe.
Okay.
So that's maybe one of the disadvantages of welding.
Of welding, okay, understood.
Okay, so let's move to the next one.
That's the twin ferrule.
The twin ferrule fitting.
Yes.
So that one, it's usually for tube or tubing.
Yeah.
And it's called twin ferrule because inside the fitting, so this is the tube and this is the fitting.
Yeah.
Once I open the fitting, I'm not sure if you will be able to see here in the camera.
I can see
I
that,
have
yeah.
what we call a front ferrule and a back ferrule.
Yeah, okay.
And what are they doing is that they are getting attached to the...
If you move back a little bit, just a bit nearer to yourself. Yeah,
okay.
That's good. Yeah,
like that?
Exactly.
Okay.
Then...
So what are they doing is that once you put the nut here, they will go inside the tube. If you want, I show you in the sketch that I have here.
Can you show us in the sketch again?
Yes. So here you can see the tube.
Yeah.
Then the nut is outside and the rings are getting, you see a little bit of deformation.
Yes.
So this is what makes that the tube does not escape from the fitting.
Okay.
So it's creating the tight connection.
Okay. And tell me, is that so if you do this once, can you then open it again and reclose it, or does it go in there and it like makes the material in such a way that it's only once?
Very, very good question. It's so famous, that question. I like it. Basically, once the fitting is tight, the ferrule will be attached in the tube forever. So that will not jump. Okay, so it will look like this.
Yes.
So on that part, you will need to cut this side. But you can reassemble to the fitting if you want. If you can use this part and reassemble the fitting. But be careful, because then all the tools that we use to check if the connections is working is not applicable anymore. So it needs to be done a pressure test and a leak test to check if the connection is tight or not.
And so that means if we lose it, basically we have to cut it and put another one and then do it again. Okay, that's the twin ferrule.
Yes.
Oh, right.
Yes.
Okay.
Yes.
Okay.
That's it.
Yeah. Okay. Well, that's so. Yeah. Considering that it's a pipe, then you really have to think about how you get more pipe to join the other pipe. So okay.
Exactly. That's it. That's it. But the advantage of the twin ferrule is that the tube is very easy to cut and to make the construction in the plant.
Okay.
So they usually are cut on site, and then they just cut and then they clean it, etc., and assemble on site.
Yeah.
So it's quite flexible in terms of tooling, etc.
Understood. Okay.
So let's go to the single ferrule.
Yes. Same
system than the previous one, but just with one ferrule. It has one advantage that very few people know. That is this kind of fitting is according with a standard. So it's not a manufacturing standard that the twin ferrules fittings or the lock fittings, many people say. They follow a standard. So if it's written in the standard, if it's follow the standard, then everyone can make the same exactly fitting, and it's interchangeable everywhere. So that's a big advantage.
Okay.
And the standard is this one, the DIN 2353.
Okay.
That is the standard that are done the fittings. So famous in Germany. This one.
Okay. All right.
Okay, let's move to the next one. The cone and thread solution. Okay, this one is the one I like it the most because it's the one that can stand more pressure. And then for refueling stations, you need usually a lot of pressure. You are working around 500 bars or 1000 bar. So it's a massive pressure for a fitting that needs to stand. So cone and thread is the perfect solution for that. It's a metal to metal union. So there are no gaskets, nothing. It's like the twin ferrule. But here on this on this kind of fitting, it has two pieces. It has what we call the gland, like it's like this, and the nut, like that, and then the fitting.
Yes.
But here, the main difference is that you remember the tube that we had before, that you just need to cut the tube.
Yes.
Now, in this fitting, you cannot put the tube inside the fitting and it's working. You need to make a thread here and a cone. So that is why it's called cone and thread, because this needs to be done a thread and then a small cone.
Okay.
So you need a tool to do that. That is a little bit complicated, or maybe a CNC machine if you need to do a lot for a specific length. So this one is very good, but from the engineering perspective, it needs to be the detailed engineering of the plant perfect, because any millimeter that does not change, we prepare the tube like this, and we say, okay, this tube 100 millimeters, 102 millimeters, but then any change on the detailed engineering, it will not match all the whole infrastructure.
Okay, so maybe can you just show the diagram again for that last one? I just want to have a look at it. And maybe you can just explain on the diagram. So you have the threaded side, and then how does that?
Perfect. So here we have the tube, where I say tubing, and it's going like this. This thread is from the tube, and this is the cone.
From the tube. Okay, understood.
That's the cone. Yes, that thread is from the tube. Then the red part is the ring, and then the other one is the gland.
Okay, okay, and
then this is a metal-to-metal connection, and then you have all the possibilities. You have elbow, T, straight tubing. So all the different possibilities are possible. Are there.
So what kind of? So that means that metal-to-metal. Can you just point to where the metal-to-metal connection is?
Yes. Yeah. It will be here.
There. Those two metals are being pressed on with a lot of power, right?
Exactly, with a lot of power. Okay. We also, yes, this is one of the more challenging parts of the fitting.
Yeah, because I wanted to ask now, so you have these two things being, that means, do you need any special tool to, push it with that much power, or do you need to measure how much, torque you need to use for the screw? Or
yes, you can use a wrench that it has a meter, so. And we can tell exactly which torque do you need, or you can just press until it's well tightened. At the end of all these kind of connections, you will need to do also a leak test after all the installation is finished.
Okay, I have two burning questions I still want to ask you, Enric, and that is, so having talked about this, it looks really simple actually, and you said so basically you can put this and then. You have the pipe or a tube, and then you make a thread, and then you put that, and then you wrench it. So basically, anybody can do this, right?
Okay. No, yes and no. Okay. Easy. That is easy, but for example, if you an eye surgeon will tell me that some kind of operation is easy, but because he's talking about his colleagues. Yeah. So it's like I will not go to a surgery with just following the instructions and the book of medicine and do myself the cuts in the eye. Right? So this is more or less the same. It's similar.
Really?
You cannot go without a little bit of training.
Yeah.
So ideally, the operators who install that have done that before, or get some mentorship or some kind of. So yes, they need a little bit of preparation, because otherwise will start leaking everywhere. Yes, it is easy, but it's easy if you have done it before, if you have seen before.
And you know what to watch out for. Okay, one more thing, just in terms of cost, So again, I think it saves time if you can, connect two tubes or pipes like that. When you compare that with other ways of connecting, maybe welding, what are we looking at? What's the case for using a fitting?
Good one. Yeah. I always say the engineers, the only unit that we use is euro or dollar, not centimeters or meters. It's euros or dollars. So okay, or any other currency, but it's term of money.
Yeah.
So correct. For the cone and thread fitting is the most expensive, because you need to do all the cone and thread of all the tube. The fitting is very expensive itself, so it's an expensive solution.
Yeah.
So what here I recommend is only use those ones when the pressure is really needed for these ones. If you don't need this big amount of pressure, then change for a normal fitting like a twin ferrule, single ferrule, or welded solution. Welded solution is very cheap, the fitting, very, very cheap in compare with the cone and thread, very standard, you can find in many places. But then with welding, you need to add the welding cost and the welding tests. So maybe in the specification, there is X-ray, so that is a very expensive test. And if it needs to be done in every single weld, it gets expensive.
Okay, understood. Plus, I mean, if you have a welded connection, to disconnect that one, there's only one way to solve it.
That's never not going to happen again. Yes,
so maybe last question, and also with a bit of an outlook. Yeah. So which is the most? We heard before which one is your favorite one. Yeah. But just in terms of the next years coming and seeing how things are developing in the hydrogen economy, which one do you think is like most popular? Which one will be seeing the most in the next couple of years? If you can answer.
It will be, yes. Definitely for high pressure, it's going to be cone and thread because it's standardized with many manufacturers. Not that many, but there are many people in that segment that are doing this kind of fittings, as we do. And then as soon as there is more demand, the price of these fittings will start decreasing.
Okay.
So obviously, it's not the same for me to manufacture 100 pieces than manufacturing pallets and pallets for this kind of fitting.
Okay. Wow, Enric, okay, unfortunately, we have run out of the time, but I can say, half of the Ph.D. for the fittings, in my view, you've already done. You are bursting with information about that. Thank you so much for sharing that. This has been a real pleasure speaking to you. And
same for me. It's been a pleasure
for sharing all this information and in this way helping the economy grow, because that's part of our mission to bring transparency. And I just want to say, if you are looking to get in touch with people like Enric and his great company Redfluid, on Hyfindr.com you can find his products plus many other products that make the hydrogen economy work, or services or things. You can link yourself up in the community, talk to other engineers, and if you like this video, please also give us a like or subscribe to this channel. People like Enric are really engaged, and so thank you, Enric, for taking the time. And also thank you so much for watching.
To you. It's been a real pleasure to do a video. I always follow your YouTube channel, and I'm so glad to be part of that.
Thank you very much. Well, we hope to do more with you sometime in the future. And until then, I wish you well. And I would like to say to the audience again, thank you for watching. All the best to you.
Thanks everyone for watching too. Thank you so much. Bye-bye.
Bye-bye.